In this lesson video, we're going to take a look at the equations of circles when we apply circles to the coordinate plane. We're going to be graphing some and talking about equations in the coordinate plane. This is lesson 6.5 for Unit 6, Day 5. And so we're going to start off just right with our formula at the very beginning, and then I'm going to help you understand what the pieces mean. So we do have a specific equation for equations of circles. And actually, before I write that down, I want to show you one other thing. Okay, back in algebra, you had specific equations for different shapes. Like a line, we could always write the equation as y equals mx plus b. The equation of a parabola curve like this, U-shaped curve, was y equals ax squared plus bx plus c. And so these are specific formulas for specific kinds of graphs, okay? And they always were in terms of y and x. All right, and so our equation of a circle is still in terms of y and x. And here is your equation of a circle. X minus the letter h, lowercase h, squared, plus y minus the lowercase letter k, squared, equals r squared. Now this looks a lot different than anything you've seen, but it also looks similar to things we've seen. Okay? What this first parentheses does is really just explain that h is a point on a graph, or the x-coordinate of a point on a graph. K is the y-coordinate of a point on the graph. And then x and y are all the points that are a fixed distance from h and k. That makes hk, this ordered pair, h comma k, that is your center point. Okay, hk is the center of the circle. All right, and so we just plug in the coordinates of h and k into this formula in standard form. And so the distance, or the difference between the x's squared plus the difference between the y's squared equals the radius squared. Okay, so I'm going to show this example to you here. The center of this circle would be at -4, 1. Okay, you can identify where the circle is, where the center is. And so basically what this is doing is saying that if I pick any point on the circle, okay, I'm just going to pick this point. Okay, there is a horizontal distance between these points, and there's a vertical distance between those points, and then this would be your radius. Well, that becomes a little right triangle. A squared plus b squared equals c squared. A squared for your horizontal difference between the x-coordinates, plus b squared for your vertical difference between the y-coordinates, equals c squared. That radius ends up being the hypotenuse of that right triangle. And so this is really just the Pythagorean theorem, but we're using coordinates to find those values. And so this is your formula you're going to need to know. So hk is your center, and then this r, just r by itself, is the radius. So r squared is your radius squared. So if the radius was 5, this would be written as a 25, because 5 squared is 25. Okay? And so we can use this information to write equations of circles given a graph, or if we're given the equation, we can come up with our information this way. So let's do some examples. All right, so in this first example here, we're going to identify the center, all right, hk. So my center is at the point -4, 1. Okay, there's the -4, there's the 1. That means h is -4 and k is 1. That's going to be important for my equation in a minute. The radius is the distance from the center to a point on the circle. Well, I'm going to look at that in terms of a vertical or horizontal distance, because then I can just count them. This radius goes from +1 at the center down to -1 here. Okay, that's a radius of 2. No matter where I drew the radius, it's 2 units. Okay, you don't have to do all these, but you can see that the radius is 2. All right, so my r is 2. Now, the diameter is also important to figure out at times, and the diameter would be double the radius. Okay, it would be from -6 over here back to -2. That's a diameter of 4. So a lot of our calculations just come from counting horizontally or vertically. You can't count diagonally, but you can count horizontally and vertically. So our equation would look like this if I plug in this information. Parentheses, x minus h squared. Well, if h is already negative, x minus negative 4 turns that into a x plus 4. So it's x plus 4 parentheses squared, because we're doing minus a negative, plus y minus k becomes y minus 1 squared equals my radius squared. So if r is 2, radius squared is 4. And that is the final equation of my circle. What I want you to start to recognize is that whatever your center's coordinates are, h and k, when you plug them into the formula, they're the opposite numbers. Negative 4 becomes plus 4. Positive 1 becomes minus 1, because we are using subtraction in our formula. So let's try another example. Okay, in this example, all right, you can kind of tell where the center is. There's not really a calculation for it. Most of the time you will be able to obviously see where the center is. Draw a diagonal vertically, draw a diagonal horizontally, and you'll see they meet at the center, which is that point there. Since this is on the y-axis, the x-coordinate is 0, and then the y-coordinate here is negative 2. All right? So the center is at 0, negative 2. The radius is the length from the center to a point on the circle, so we can just count that horizontally. 1, 2, 3. So your radius is 3. That means the diameter is 6. And we can start to write our equation. Now, I'm going to write this down here because we can simplify it in a minute. H is 0, k is negative 2. Remember, the center is always hk. Don't worry about why we use h and k. Those are just chosen letters to represent the center of a circle, because I don't want to use x and y. X and y are always parts of the equation. So when I start to write my equation, I'm going to do x minus h, which turns out to be x minus 0 squared, plus y minus negative 2 squared equals 3 squared. Well, I want to simplify this because that looks really messy. Sorry if you couldn't see that. It looks like this. X minus 0, I don't have to leave as a binomial like this, meaning two terms. X minus 0 is just x. So that gets rid of our parentheses altogether, and this is just x squared. Okay, plus minus negative 2 turns into y plus 2 squared, and 3 squared is 9. So that's the equation of this circle. All right? I want you to try and come up with the third part of this example on your own. That means you'll need to pause the video and try this problem on your own. When you're ready to check your answer, you can click play to continue. Okay, this is what we should get. Since our circle has a center at negative 1, 2, a radius of 2, the equation is x plus 1 squared plus y minus 2 squared equals 4. All right, and that leads us to the next set of examples. I can also start with a given equation and work backwards to find these pieces of information. Now, you'll see where it says graph down here, and you don't have any graphs in your note packet to use, so we're going to do these graphs in class. I'll give you some graph paper, and we can do the graphs in class. Okay, we're going to number these, though, as 1, 2, and 3, so you can number your graphs in class. But for number 1, we're going to look at the given equation, but I want you to start with the generic formula. So up here, above this box, I want you to write x minus h, parentheses squared, plus parentheses y minus k, parentheses squared, equals r squared. Because the more you write this, the more you're going to have it sink into your memory and be able to use it on a test. So in our first example, if it's supposed to be x minus h, but we have x plus 1, remember minus negative is what turns that into a plus, so h is actually negative 1. And we have y minus 3, so k is just 3. Remember, h and k end up being the opposites of these numbers. Positive 1 turns to negative 1, negative 3 turns to positive 3. So the center is at negative 1, comma 3. And then r squared equals 16. If r squared equals 16, we need to take the square root of that to find out that r is 4, which makes the diameter 8. And we can use these pieces of information to make our graph. So we're going to do that part in class. I'd like for you to try the next two, number 2, number 3 here on your own. Again, pause the video to give yourself some time to do this. But then when you're ready to check your answers for these 3 blanks on each one, don't worry about the graph yet, then you can continue by pushing play. All right, this is what you should get for 2 and 3. Okay, for number 2, the center is at +4, and then there is no k value. There's not y minus anything. Remember, that means that the y coordinate of your center has to be 0. The radius is the square root of 36, which is 6, which makes the diameter 12. Over here in this example, again, there's just x squared, so it's like we originally had x minus 0 squared to make it just x, so the center's x coordinate is 0, and then the opposite of 2 for this k value is -2, so the center is at 0, -2. Your radius is the square root of 20, and here's where you have to be careful. Remember, 20 equals r squared. So to find out what r is, we have to take the square root. So you can write that as the square root of 20, or we can use our calculator and find out that that's about 4.5. Now, when I double that, if I use the exact value of square root of 20, I get 8.9, but if you just doubled 4.5, it'd be 9. So I'll take either of those answers. Okay? And so we'll look at graphing that one a little bit more later because we're just going to get an estimate when we use this kind of a problem. All right, so we're going to finish up our video here with one side of this, and we'll save the other one. You can try the other one on your own. We're going to do this one in the video, though. So let's say these are actually several different problems. If I give you information, you can write the equations from that given information pretty easily. So like if I have a center of 3, -2, and a radius of 3, that's all the pieces I need to go into this. X minus h squared plus y minus k squared equals r squared. And so all we have to do is plug in h, k, and r. This would be x minus 3 squared plus y plus 2, because it's a -2, squared equals 3 squared, which is 9. And that's your answer. That's all you have to do. If I give you a graph, we actually did a couple examples like this at the beginning. Okay, your center, okay, find your center. That's the point -1, 2. And your radius is 1, 2, 3. So we plug that in. It becomes x plus 1 squared plus y minus 2 squared equals 9 again. But this last portion is where it gets a little bit tricky. I'm going to give you the center, h, k, but then I give you a point on the circle. So it's like I give you the center and another point here somewhere. And what I want us to do then is to use some information to find that. So what we will do is use x and y as 3 and 1. And so we're going to use our formula here, but instead of plugging in just for h and k, we're first going to plug in 3 for x and 1 for y so that I can solve for r squared. That's what I want to know for my formula. So I'm going to use my formula, but instead of x minus h, I'm going to do 3 minus 2 squared plus, instead of y, I'm going to use 1 minus -2 for k becomes plus 2 squared, and that's what equals r squared. So I'm using my formula to find the missing piece right now. 3 minus 2 is 1, 1 squared is 1, 1 plus 2 is 3, 3 squared is 9, so r squared is 10. Now notice that I've gotten r squared. I actually don't need the radius itself. I just need to know what r squared is. So my formula is now, instead of 3 and 1, I'm going back to using x and y. X minus 2 squared plus y plus 2 squared equals r squared, which is 10. Okay? And we're going to save the very last one for in class, because this kind of problem is going to, we're going to use the circumference to find the radius. So if you want to try any more of that on your own, you're welcome to. Otherwise, we'll go over these in class.